In this video, I'll show you how to solve a linear system with three unknowns using Cramer's rule. What we have is three equations, and each equation has three unknowns. And what we're expected to do is use Cramer's rule to find out what x, y, and z is. Cramer's rule for a system of three unknowns looks like this, where you have x, y, and z can be found using the determinants of k, b, and c, a, k, and c, a, b, and k over delta, which is defined here. The first thing that I would like to do is make sure that all three of my equations are in standard form, meaning that all the terms containing variables are on one side. And as you can tell, they all are. X, 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 y, 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 and z, z, z all are on the left side. The next thing that I want to do is write this out in rows and columns, and this is something that I personally like to do. It helps visualize what's happening. We have the coefficient 1, 2, 3, and 14, the coefficient 2, 1, 2, and 10, 3, 4, and negative 3, and lastly 2. And this is my A, B, C, and D column, and this is my 1, 2, and 3 row. The next thing that I'll do is find out what my determinant is for A, B, and C, which will represent delta. And to find what that is, what I have to do is rewrite the first two columns A and B right beside C. Let me show you what I mean. So right now, it would look like this. 1, 2, 3, 2, 1, 2, 3, 4, and negative 3. And we'll rewrite these two columns right here. I'll use another pen. 1, 2, 3, 2, 1, and 4. And now, to find out the determinant, I need to find the product of these three, add them to the product of these three, add them to the product of these three, and then subtract by the product of these, and these. So let's go ahead and do that. And this is quite involved. There's a lot of numbers here, so pay attention with the multiplication and adding and subtracting. 1 times negative 3 is negative 3, plus 2 times 3, that's 12, plus 3 times 2 times 4, that's 24, minus 3 times 1 times 3, that's 9, minus 4 times 2 times 1, that's 8, minus negative 3 times 2 times 2, negative 3 times 2 is negative 6, times 2 is negative 12. So minus negative 12. Using my calculator, I'll add these up. Negative 3 plus 12 plus 24 minus 9 minus 8 minus negative 12. And this gives me 28. So my delta value is 28. Now I have to do the same thing, the same process for each of these determinants. So the next one that I'll do is x. And whatever I find for x, I'll divide it by 28. Now this, I said, was my d, but it's actually represented as k here in Cramer's rule, so I'll change this into a k. And so we have to find the determinant of k, b, and c. I'll make it right here, and then I'll transfer it below. So 14, 10, and 2, 2, 1, and 4, 3, 2, and negative 3. Remember, I'll rewrite these two columns right beside the last one. So I'll transfer this now below. And now I need to do the same thing as before. I'll highlight what I'll add. And using blue, this is what we'll be subtracting. So let's go ahead and do that. 14 times 1 times negative 3, that is negative 42, plus 2 times 2 times 2, that is equal to 8, plus 3 times 10, which is 30. 30 times 4 is 120, minus 2 times 1 times 3, which is 6. 4 times 2 times 14, it's like saying 8 times 14. That is equal to 112. And lastly, negative 3 times 10 times 2. That is negative 60. Using our calculator, we have negative 42 plus 8 plus 120 minus 6 minus 112 minus negative 60, and we end up with 28. So 28 divided by 28, this right here represents our delta. We end up with x is equal to 1. Now the unfortunate thing about this is that we have to do it for y and z. So instead of showing you the whole process, this is what you should have gotten for y and z. So after working on this for the past 10 minutes, I finally got my y and my z value. And my answer, my point of intersection for these three equations is 1, 2, and 3. And so there you have it. That is how to solve a linear system with three unknowns using Cramer's rule.